actually really easy with functions because all you have to do if you want to add, subtract, multiply, or divide, if you want to add, you just slap a plus sign in between whatever they give you. And if you subtract, you put a minus sign. So there's nothing special about it being a function. It's the underlying thing. So if they're polynomials, you're just combining like terms. If they happen to have denominators, you may have to find a common denominator. If they're completely unlike, sometimes they don't simplify at all. You know, it's just 2 plus square root of x. Okay. So there's no way, again, that I can really say, well, this is what it always looks like. It just is what it is. So first off, back to remind you one last time about evaluating functions. We've seen this 50 times, but this is going to be 510. Okay? So if I want to evaluate a function and I have f of negative 3, I am just going to plug in negative 3 or whatever is there, and then get out my faithful companion, because wherever I go, thank God you can't get arrested for calculating and driving. It's only texting. And I am going to type that in. Okay, would help if I looked up to see that I was still up in the exponent. I need to come down. And this is exactly as much work as I would need to see. Basically, if you're just evaluating a function and you're just plugging in a number, no matter where it is on the test, there's nothing you need to show me as far as the actual work goes, other than I'm replacing the letter x with this particular number. Everything else is on the calculator. You don't have to sit there and say negative 3 squared is 9, and then change the next one and the next one. So there's no work. It only is going to be work if there's something else going on. If I take this square root, and now I'm going to plug 4 in, that's the square root of 4, that's 2. But you know, you can go from here to here via Casio. You don't actually have to show me that intermediate step that says 8 minus 4, and then take the square root. You can just type the square root of 8 minus 4 into your calculator screen and get the answer. So I don't expect work. For plugging in something other than a number, I would need to see some work, because the answer is probably not going to be this. That's what I get when I take this and replace the letter x. But that they usually don't leave. I mean, if they do leave it like that, then yes, there is no work because there's the answer. But most of the time, they would probably multiply that out. So I would be here going, okay, FOIL this. So that's a squared. It's 2a plus 1. Distribute the 3, the negative 3. And then put all this stuff together. So a squared, 2 minus 3 is minus a. 3 plus 2 is negative 1. And here's my answer. So that one I'd expect to see a little algebra, unless you did all that in your head, which I'm doubting. My rule of thumb is if I can't do it in my head, you can't do it in your head. The only other thing that might happen to you if you're just plugging in numbers is you try to plug in a number and it just doesn't work. Oh, that was me, sorry. Okay. So if I plug in 10 up here, I can try it, but because I'm going to get negative under a square root, now I say undefined. So remember, on this test, there is no answer with an I in it. That's not going to happen. This test, it's all real numbers. So basically, you could make sure that the mode on your calculator for the first test, the mode was complex, because you could get answers like 4i, 6i. For this test, you just need computation mode. That means that if you tried to simplify something like the square root of 8 minus 10, your calculator calculator tells you, I can't do that, not in this mode. So you would know that when you see something like that, this end thing is undefined. Okay, so slight change. You always have to know over what kind of numbers you're doing. Now, if I want to do the same evaluation thing, but I would like to add in something else, like addition or subtraction or anything like that, it's going to be written possibly like this, where what you're supposed to do with the functions is written first, so you're supposed to subtract those two, f minus g, and then you're going to plug in a negative 8. But you can think of this as f of negative 8 minus g of negative 8. So I don't actually have to do the subtraction first. If I have a number, I can evaluate those two things. I can find f of negative 8 is negative 8 squared minus 3 times negative 8 plus 1. And I can find g of negative 8, which is 8 minus negative 8. So this one is going to be 4, and this one is going to be 45. And that's your Casio, whatever, your brain. And then I can use these two. Okay. Whoa, that's not what I want. Not a highlighter. These I can just put back in there and subtract. So I can say f of negative 8 is 45. Let's add with a 5. That's 45, and g of negative 8 is 4. And I get 41. And there's my answer. So I do expect to see some work because there are pieces of this. Each individual piece is just showing me, I know what I'm doing. I'm just plugging stuff in, and I'm like, okay, I get that. You obviously don't have to show me that. I didn't say I did it right. Oh. I asked you. Okay? That's what I did in my head. I know what I forgot. I forgot that was positive. So 64 plus 24 is 88, plus 1 is 89. So you're going to help me. But it's very polite of you to say, that's not what I got. Not comma. What the hell are you doing, lady? My Casio is telling me. What I did was, I forgot this was a double negative. I said that was 64 minus 24. But it's not minus 24. That's positive. You know, the kind of mistakes you would never make as a student. 13, 83. Oh no, subtracting. You notice this is, you know why this is happening, right? I'm not using my freaking Casio. Yes, sir.
Aren't you supposed to add something? I think that equal 4 is not supposed to be a positive 4.
That is a positive 4. But I'm subtracting. The original problem said find what f is and find what g is and subtract them.
Oh.
So I take these two numbers and then they want me to subtract.
Oh, I see.
As opposed to finding f of x minus g of x, where everybody keeps the x's, and then after that's all done, plug in negative 8. I mean, you could do it that way, but that's usually much longer. So whatever the arithmetic symbol is separating them, if you're plugging in numbers, you just do it with numbers. So g times h of 0 is g of 0 times h of 0. So I go up here. G is square root of 8 minus x. So g of 0 is square root of 8 minus 0, which is 2 square roots of 2, because that's what your Casio telling you. God knows you better check me. And h of 0 is 2 over over 0 plus 1, which is 2. So here, I'm going to say 2 square roots of 2 times 2. So that's 4 square roots of 2. And that's my final answer. So this is the work, really. You know, figure out what happens when you substitute the numbers in, and then go back and multiply them. Or add them, or subtract them, or whatever the hell they're telling you to do with them. It doesn't have a lot to do with functions. You know, evaluate a polynomial, and then do some addition, subtraction, multiplication. And once again, there are some times when you go to plug things in, and they screw up. So this would be 2 over minus 1 plus 1. 2 over 0, which is also undefined. A different reason than the other one's undefined, but still undefined. Okay? Because as we saw, we were talking about domains in the last slide. Remember that word domain? Good thing, because it's coming out. Okay. It's all over this test like a bad smell. What are we going to write? Domain. Okay. So, nothing for my calculator here because there's no numbers to plug in. So see how calculator intensive this was? This one, no, because you're still using variables. But all of these, there is work, but it's arithmetic work on the test. Then you have this kind of thing where you're adding, subtracting, multiplying, dividing, but you're doing it with the x's still in. So this looks a little different. You're not going to get numbers. Now I'm going to have, this is r of x minus t of x. So r of x is x squared plus 3, and t of x is x plus 4. Here is where you have to be careful. You can't just write minus x plus 4 with no parentheses, because that only subtracts the lead x. It's minus however long that thing is. You're subtracting the entire expression. Could be long, could be short, but it needs parentheses. If that's a plus sign, you don't need parentheses. Wouldn't matter. With a minus sign, you always have to have parentheses. So this is going to be x squared plus 3 minus x minus 4. X squared minus x minus 1. And now, I need to know the domain. You know those questions I asked you long ago and far away? That you're thinking, oh hell, I was going to do that this weekend. So what's the domain? That would be it. Sound familiar? No, that's just like blah, 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 blah. The only thing I'm looking for in domain is either dividing by 0, no denominator, or I'm not allowed to have a negative under square root. No square roots. So if those two things aren't there, I can put any number in there I want to. In other words, plug in whatever number in the universe you want, nothing screws up. Oh boy. Long week? That's all I'm saying. So this is saying divide. Take the r function, x squared plus 3, put it on top of the t function, x plus 4. And I'm done, because there's nothing to do there. Now the other one, I had some simplifying to do. There were polynomials, I distributed, collected like terms. Yes, sir?
You don't use the person.
You mean like division?
Yeah.
No, because that's really not simple. It would be like, 1 and some remainder, but that's not a simpler expression than the one I'm looking with. If it factored and things canceled out, I would do that. But I wouldn't do, you're talking about polynomial division, right? You're talking about this?
Yeah, so get x minus 4 minus 13 over x plus 4.
Yes, but that's not a better version of what I already have, so you can see that. That's a, simplifying would be if this factored and I could cancel out the top and bottom. But division, polynomial division is usually not making it simpler. It's changing parents. You know, it's like having 5/2 or 2.5. In an algebra class, you usually leave it 5/2. So that's the same thing we do with polynomials. Yes?
Can you ask why is the negative infinity of the domain? Why is the negative infinity there?
I've covered it repeated times, and apparently I just, one of those lectures where it's just me, myself. Notes I'm writing like in a diary. Dear diary, today I thought of infinity. Later on, somebody may read it, but you know, no time soon, no rush. So, once again, the fateful question. Look at how many sneaky ways I'm making you do domain and you're trying to avoid them all. What would be the problem child here? What would be the one number I'm not allowed to plug in?
-4.
Oh my God, see? You're good at that. So x can't be -4. So that means I am looking at, thank you. I am going to skip -4. And I am going to pick all the other numbers I can. So my domain will go minus infinity to -4, -4 to infinity. That is, go up to -4, jump over it, start again on the other side and keep going forever. Yes, sir?
What would you include 4?
Because that's the one thing that's missing. In other words, it actually looks like this. If I were to try shading it on the number line, I would be able to put little dots on every single number except -4. So that hole is what I'm showing when I put those things on the end. That means you don't include that point. So that's how you show jumping over an individual point. Okay. Sounds vaguely familiar. Somebody once told you that. It's in a dream. Multiplying S.
I have a question.
Oh, sorry. I didn't see.
It's okay. For the number 8, you got -infinity. So why in number 9 is there a number?
Because
Like, what's
this
the
has a
difference?
problem.
How is that a problem?
I can't divide by 0.
But that's not 0.
No, but if -4 is, it is 0. In other words, if I were to plug -4 in there, now I'd have a 0. So I have to leave out -4.
Okay, so when you use a number, you have to not leave it with x. You always have to put the opposite sign of it.
You have to solve the equation that's in the bottom, set equal to 0. That equation could be linear, could be quadratic, you may have to factor, it just depends on what's happening. I'm solving this.
Okay.
So if that's a quadratic equation, I have to set that quadratic equal to 0, there's gonna be 2 factors. And I can't have either one of them. So, S is 2 over x, T is x plus 4. So that's just gonna give me 2 times x plus 4 over x. So what do I have to do now?
0.
Zero. X can't be 0. I don't care about the x plus 4 on top. Because I can have 0 up on the top, I can't divide by it. So this is going to go for my domain, minus infinity the 0, jump the 0, keep going to infinity. If you can't see it, you can draw a number line, but you don't have to show me a number line. You know, you can look at that and say, I'm leaving out 0, and just see the domain. So there might not be any more to show, okay? But it's the same as the other one. I've got a hole here, and I am taking all the rest of the voids. So there's me jumping over the hole at 0. So everything I've done on those first 2 pages is to show you, plug this in, simplify. That's it. Plug in numbers, plug in letters, plug in combinations, you can add them, you can subtract them. I can do a million things, which means I don't want you to freak out when I show you this.
For the test, are we gonna have a phone number?
What formula? The functions? Yeah, I'm gonna give you some function and say, do something to it. Okay. Let's not look at the scary part just now. Let's just look at that. That thing is called the difference quotient. All you really need to know is that's going to be something that you're going to be asked to evaluate a million times. And the reason they're asking you to evaluate this over and over is because that is part of a very, very, very important definition in calculus. And allegedly, some of you people in here are continuing on to either business calculus or real calculus. So you will see this definition, and you will know it like you know the quadratic formula. This is part of it. So what they're doing now is they're giving you practice evaluating this thing. So this is what you're going to evaluate, and I'm going to give you some kind of F, just like I did before. When I set up here, tell me what S times T is, I give you the S and I give you the T, and you take those two and do something with them. So when I'm asking you to evaluate F, I'm going to give you different F's. Here I give you a linear one, here I give you a quadratic one. Whatever I give you, you plug stuff in and you evaluate it. So, find F of X plus H. So that's the very first thing we were doing. That is this. Find F of A plus 1. Pop out whatever the letter is, replace it with that other letter, A plus 1. This time around it says, pop out the X, and replace it with X plus H. So F of X plus H is going to be 5 times X plus H minus 2. I took out the single letter X that was sitting next to the 5, and I wrote in X plus H. Which is kind of weird, take out an X, put back an X. Let's just go with the flow. It's like, take off that green shirt, put on the other green shirt. Okay, whatever. So, you are changing, they look really similar, okay? But I'm going to take that out, and I'm going to replace it with that. And then I simplify this. And when I'm done simplifying, nothing much happens. I'm okay, I'm okay. There you go, are you happy? I'm done. Now, the other thing is to put it together in something more complex. So this next part is like these up here, where I say, okay, subtract them, divide them, multiply, where I'm giving you instructions with a couple of functions, and I want you to put them both in and do some, you know, add and subtract and whatever. You're saying, okay, whatever you got, I'm going to do F of X plus H minus F of X over H. So I already have this. I just figured it out. That's F of X plus H. So I'm going to take out, that's F of X plus H, and I'm going to write in that expression. I also already have this. That's my original function. Now other words, it says subtract off f of x, the original. Okay. Whatever. If you give me this out of here, I'll do what she says. So, the important part is, when you put a minus sign in front, wrap it with parentheses, and just put in there whatever they say. I could have said subtract 2, subtract z. So I could have told you subtract it, you just copy it into it. And over h. So now I commence with the low level simplifying. Minus 2, x plus 5x plus 2 over h. So just like I was doing before, I put together stuff that matches. So here's 5x minus 5x. 2 minus 2. I'm left with 5h over h. Those go. I'm left with 5. If you do this right, every time h cancels at the end. If you screwed it up, like you forgot to wrap it in parentheses or something like that, those won't cancel, and you know you did something. So, what can make this work? Yeah. Yes.
I have a question. That would define why
That would be the slope of the tangent line. Well, in this case, it is a line. That would be the slope of the line. That's the calculus definition.
one question there. What are you supposed to do with all that steps if you can't know the slope?
Because we don't know how to take a derivative in calculus.
No. Fx equals 5x minus
Right.
5
Is the slope.
is the slope. So
What's the slope of number 12?
in that case, you need to use the formula.
No, I can tell by looking at it. 2x minus 3.
You have to slope.
No, that's a formula for finding slope. The reason this is coming out that 5 is a slope is because it's a straight line.
Yes.
This one has a variety of slopes depending on the point you're at.
Yes, because two branch.
Right. But it's that, you don't have to worry about. In calculus, that's what you're worried about.
So in the case of the slope, you're supposed to define two slopes.
No. I'm finding, what I would actually be coming out with is a formula that if I plug in a particular x, will generate me the slope. So I have a formula, and if I plug in x equals 1, that's the slope of the line at x equals 1. If I plug in x equals 3, that's the slope of the line at x equals 3.
Okay.
That's what I'm finding. Yes, sir.
Remind me what time is the first step? I know you get
This?
Yeah.
I plug x plus h in for x. Let's put it this way. Let's change it. Because you were following me previously. What's f of 6? Right? What's f of z? Right. And what's f of a plus 1? So you are just a little plug-in machine, and whatever I tell you to plug in, you plug it in, and maybe you just get the answer, maybe you have to do some cleanup, maybe nothing happens. This is saying x plus h, so what you plug in that little replacement slot is x plus h. And just like here, when I plug in something like that, usually I have to do some cleanup, so I can actually do some more work. When I plug in this, I can't do anything, that's what it says. So here I plugged in x plus h, and then I, distributed and see if it can match.
I was doing the opposite. Plugging into the x plus
Don't do that. Okay. That's my advice, my professional advice, okay? Stop that. So I have any over here, or was I always stay here? crazy. Same question. Worst thing to plug into. This is the determining factor, okay? So this time around, for my x plus h, it's going to go in two different places there. So I take out the x and replace the x plus h. Take out the other x and replace x plus h. Now that one's got a hell of a lot more to do, a lot more ways to go, because I can keep traveling here. I can square it, I can collect like terms. I have more work to do, because this is not just a simple single letter of the alphabet anymore. It's not a simple function. So I say, okay, I can FOIL you out. And I can multiply by -3. And then I start going up and down, and looking to see if anybody matches, anybody put together. And the answer is no. So that obnoxiously long thing is my answer. You know, sometimes with a windshield and sometimes with a love. So, he said, okay, well that was refreshing. Now what the hell do I do with it? So now, we're gonna put that entire obnoxious, long mess in here. It says, give me f of x plus h. Unfortunately, that's what it is. In you go. You see how your hand is gonna be like, you know, one of these. So if you don't show me work on this, no, you didn't do that in your head, okay? Trust me, dude. Okay? So x squared plus 2x h squared. 8. And then, God help us all, still going, minus this crap. Minus the original one, because I have the second piece that comes after I do the subtraction. So now it's minus x squared minus 3x plus 8. Close it off. Over h. Holy moly. Now, me, I understand totally if on a test, you just want to change all these signs and erase that. Because that way you don't have to copy it all over. I'm going to copy the whole damn thing over so you have it in your notes that I get from the test. It'll be perfect time. So this is x squared plus x squared minus x squared plus 3x minus 8. Oh. Okay. And now the hunt begins again. Can this thing compress down any? Can I collect up some stuff and make my life a little cleaner? Yes, there should be stuff now. Okay, right out of the gate, I've got x squared and x squared. I got 8 and 8. 3x is gone. So I have left you, and you. So that is 2xh plus h squared minus 3h over this guy. And I told you, if you did this right, that h has to cancel out. That doesn't mean that. That means I'm about to use the F word. Oh my dice. It's almost like we're in an algebra class. Okay? And it's unfreaking believable anybody expects you to do that. I'm going to take out a common letter H. I don't know how I made it this long with this kind of work. And now, here at the end of our time together, I can finally cancel that piece of matter. and get the actual answer. So, one of these on the test. Can you see what the problem is? Yes, sir.
This one was an option, like over the two branch, the two slope, the
Yes.
two branches.
Yes. Now, it's a little more complicated than I explained it because there's still an H in there. In a calculus class, you would actually have to take the limit as H approaches 0. That's what you do. You will see when you take calculus, within the first, say, 3 weeks of class, you'll be staring at this again. Okay, so the moral of the story is, it's not that this method is bad, it's how bad that thing is. What if that's x cubed? Oh my god, it's twice as big, you know what I'm saying? I mean, it doesn't have to look like much to make this hideously long. So, when you open up your homework, I want no screaming. They're gonna look like this, okay? So brace yourself. But notice, it's not like the radical stuff. It's not like the square roots where you're gonna get totally lost. It's a lot of recopying, but it's not hugely complicated. So, we add, subtract, multiply, divide. We put it all together in that creepy little thing called a difference function. Now we're going to do something with functions that you cannot do with arithmetic. This is called composition. I cannot compose two numbers. I can compose music and I can compose functions. I cannot numbers. What composition does is take one function and drop another one inside. So if you think of a function as a machine, okay, where this function, no matter what I drop into there, the number 1, it doubles it, spits the answer out. The number 10, doubles it, spits the answer out. Picture your dog, doubles it, spits the answer out. It doesn't matter what you drop in. Into this machine that doubles everything, I can dump pictures, cash, numbers, people. Doesn't matter. It doubles it and spits it out. And I can drop another function machine. So into there, I could drop a different machine and it would double the machine and spit it out. So you don't have that with numbers. You don't have that idea that I can put a 3 inside a 2. They're just a 3 and a 2. That's a solid. But I do have that with functions. So here's the symbol for composition. It's like, looks like multiplication, but it's open. It's like an open circle. That's F composition G. It's this thing that I move around. It's not that. But I'll say it again just in case, because I can see you all panicking. Okay, so what it means is, it means this is going into there. So when I write F composition G of X, it means into F, I am going to drop G. Sort of like, if you want to think of, if that's a 2, the 2 goes into here, the G goes into there. So that tells me that I'm going to take G of X, and it's going to go in for the X's. Sort of the same thing I was doing before. Instead of explicitly saying, drop 5x plus 4 in there, I'm closer and I can say, drop George in there. George is 5x plus 4, but I'm more familiar now, so I don't have to tell you his last name, okay? So you say, okay, George, in you go. So I pop out the x, and I write 5x plus 4, and I square it. I pop out the x, and I write 5x plus 4, and that. So that says, whatever's here is going into that one. It changes backwards the same way numbers do. when I write, if I were to say find f of 3, that says take 3 and plug it into f. This says take g and plug it into f. So there's g, and you go. And no, I'm not done. More annoying multiplication. Not as annoying as the other one, but still annoying. So 25x squared plus 40x plus 16 minus 15x minus 12 plus 1. 25x squared. 40 minus 15. 25? Seems like it should be. Oh, okay. That was 10. Okay. 16 minus 12 is 4 plus 1 is 5. That's much more important than just stop. Okay. I know what you want to do, because now you're little machines. Now you want to factor out of 5. Aren't you dying to factor out of 5? No, you're just not. You're not, no, I was going to touch it. But you don't have to. The reason I factor is to get something to cancel. Nothing's going to happen. So the answer will just look like that.
If you do factor though, is that incorrect?
No, but you won't see the answer.
Okay.
You know, you'll look down and you realize, oh yeah, there's the one step
And how
above
come
it.
you don't have to factor?
Because there's nothing under to cancel it.
Okay.
You factor to do something else.
Uh-huh.
So if there's nothing else, we're done.
Yeah, it's like x squared x.
If this was over 10, I would factor out 5 and then I could cancel a 5 and a 10. But see, there's nothing there. So now I just be entertaining myself.
Yeah, you just be having the same thing written in the same.
Yes, exactly. And God knows mathematicians love to straighten things up, but we're not that simple. So this time around, this says take F and put it into G. So now it's this great big long one. Let me write them over here without all the crap around it. It's easy to see. So here's my f of x. G of x. So now this says take f and put it in over there. So it's the reverse. And it does not necessarily give you the same answer. So now the shell, the outside shell that I'm plugging things into is G. So it's 5. Here goes my drop-in piece. X squared minus 3x plus 1. And then my plus 4. So now I multiply that stuff out. I have a little bit of cleanup, not as bad as the other one. And I can just put the numbers together. So totally different answers. Now, on a multiple choice test, they'll have them both, just in case you do it the wrong direction. You know what I'm saying? If you put the wrong one in, do it in the wrong order, you can get the other answer. So they want to make sure that you're doing this thing the right way. And by they, I mean me. Act like there's some anonymous person out there writing your test, but that is me. That way, this is, no, I didn't make that crazy ass problem. That was them. The people designing your test. Okay, so once again, it's not the actual act, that's the big deal. It's what you have to plug these creepy things into. You know, polynomials, okay. Then it starts to get worse. What if they have square roots? What if they have fractions, God forbid? It's what you're putting together. It's not needed. The composition is the same. Take this one, dump it in there. So G into F. So this says take the square root and put it into here. So this is 5. Square root of 5x plus 5 squared minus 1. So I took the square root and I put it into this. square root. As you remember from those nightmare you're still having, the last question on test 1. Where you squared both sides. Square root comes out from under. So I get 25x plus 25 minus 1. And then I can just put together a little number. And yes, there's more here. It's not just going like the beach. But wait, there's more. If I put f into g, now I'm putting this in underneath the square root. So this is the squared one inside the square root. So the square root, take out the single letter x, and we replace it with 5x squared minus 1. And now I multiply. I may be having to do a little bit cleanup under here. So that's 25x squared minus 5 plus 5. Those go. That's going to give me square root of 25 is 5. Square root of x squared is x. Assuming x is positive. I'll go ahead and yes, sir.
In that case, it will be negative composite. So that composite fraction will be a function.
Oh no, that's a, you mean the, well, technically it's the absolute value of x. It's not plus or minus x.
Okay.
You know, the technical definition, which we rarely use, is that. I saw a hand up here. No? I was always saying that. It's been a long time. Okay. So here we go, getting creepier. Because, you know, all I have to do to fail everybody in the class is make the whole test fraction. Just opening it, you know, the heart attack alone. That's a lot. I said, she can't do that, can she? You can go back now, tell your friends who didn't show up to class. She said she could put every problem fraction to the test. I didn't erase everything up there, okay. So, now I have numbers. So even though this looks like potentially it will be a creep fest of epic proportions, it's not. Because with numbers, I can go this to this, and then that to that. So it's step 1, 9 into G. Okay? And then step 2 is 10 into F. So I'm doing 9 into here, and that gives me 10, and 10 into there. So I'm just moving backwards. Put the 9 into the G, get that, put that into the F. So this is 3 over 10 minus 4. And go right into your Casio. And like this here. Today's is anything worse. Now, I could find the thing with the x first and then plug the 9 in afterwards, but you don't have to. You know, when I was doing them, remember with the numbers up on top and I'm adding and subtracting, I just use the number there. So I can do the same thing with composition. But you're always chaining backwards. Composition says this into this. But this time around, since I have something other than an x, first I put the 9 in there, and then I take that answer and put it in the problem. So this goes, 6 goes into F, and then when I'm done with that, I put that one into the G. So first is 6 goes into the F. And now this is going to go into G. So notice, this is way easier because I don't have to deal with all the X stuff. Plugging in the numbers, no matter where they show up, is by far the easiest thing. You plug in the numbers, it's into the Casio, you move on with your life. It's the ones that leave X in there without doing a number where you have to simplify, multiply, and collect lectures. Okay? So in other words, you'd like to see a lot of numbers on the test. So, here we are again. I think I didn't do one of these for you. Didn't I leave this and not do it? So now we're going to do it again. How many times can I draw a picture and ask you crap about the picture? Okay. Well, apparently this isn't ending yet. So now I'm not just asking you to find like f of 3 or g of 2. I'm asking you to do subtraction. That means you have to find f of 3 and g of 3 and subtract them. So let us recall back to the beginning of time. F of 3. So I go to 1, 2, 3. I go up to here. And I need the y coordinate at that point, which is 4. I'll wait. I know, it just disappeared over that. Okay, you with me? I'll pause there. Yes? Oh my God, you're not even nodding. It's like you're frozen. Are you nodding? Should I nod? Should I agree? Did you screw it up again? If I should stop this, I don't have a big eraser. Okay, G of 3. Still go to 3, but this time I'm on G. So I go up to there, and that leads me to 1, 2, 3. In case you're wondering where I keep doing that, I gotta get to go away from that drawing. The answer's 1. Notice, like the other problems, there's virtually no work. It's observation. So you stare at the drawing, you pick the numbers from there. Yes, sir?
Look at 4 and 3.
Look, and you know what? The guy next to you is laughing, but he has no clue either. He's like, dude, I can ask that. He probably asked you to ask that question. Okay. So, go to 3, that's your x. That's the y that goes with it. So I go out to 3, I go up to the blue curve, because that's f. And I want to know, now I'm at that point. So what's the y coordinate at that point? 4. That's the point 3, 4. So that's the answer. So here, I'm on the G curve. So now, I'm still at 3, but I go up and I stop at the red curve because that's G. So when I get to there, I need the coordinates at that point. And that's 3, 4. So there's the input, there's the output. Okay. So here we go. G of -2 over f of -2. So, my journey begins again. I go to -2, and I go to G, which is way the hell down there. So what's my answer for G of -2? Don't say that like I'm an idiot. I can't believe I don't know that. -2. I'm traveling to the blue curve. So what's f of negative 2? Compared to the hell you just went through, don't you want a lot of these on the test? See, this is what I mean about this test. You could have problem number 8 be that stuff we were just doing, and problem number 9 be this. You know, they're all over the map. They're not all super long. Some of them are just super quick. What I'm telling you is do the homework, but don't freak out. Okay. So now I have composition. So I'm going to do the same thing I was doing up here. I'm going to go this to this, and then that to there. So I start by saying, what's f of 1? I go to 1, go to the blue curve, what's f of 1? 2. So now 2 goes into G. Remember, it's 1 into F, that answer into G. So now I go to 2. Let's see here. There's 2. What's the other half of the point? 4. 4, go all the way up to here. That's my answer. That's what comes out at the end. So negative 3 into there, that answer into there. So negative 3 into G. So 1, 2, 3. What's my y coordinate for that? All the way down here. It's G, so it's a red one, right? So it's negative 4. Then that negative 4 is going into F. So I can have 1, 2, 3, 4. And what's my coordinate for F? Negative 2. And I leave you with a function touching set. I can compose a function with itself. And it's just as nasty as it sounds. Okay? It's negative 3 going to go into here, and that's going back in the same function. So, f of negative 3. I'm going to use my little pointer. What's f of negative 3? 0. Now I'm going to do f of 0. See there? No work. Just stare. And thus, I believe, we are done. A wonderful weekend. I swear to God, it's